Welcome everyone. This is the first web page test live of the year of 2022. It's been a little while, but I'm glad that everyone here could join us. So once again, sorry that we're a few minutes late. I was still, I guess, figuring out the back end of this whole enterprise that is StreamYard. It's my first time using it, so thank you for your patience. But once again, welcome to WebPageTest Live. This is not an episode of Guess Who's Coming to Dinner. And I am not Tim Cadillac. My name is Henri. I'll be your host with the most today. Shout outs to Tim. He wasn't feeling amazing. So he pinged me and asked me if I could fill in for him. And I absolutely could. So this is why I'm here. And you're going to see me a few more times, a bit more often at this amazing channel that is the WebPageTest Twitch channel. So like I mentioned, this is our first WPT live of the year. We're happy to be back. We ended the year. We were a little busy, obviously, and we unfortunately did not have as many streams as we wanted. But we are going to get going again, and we're going to stay busy, and I'm actually going to talk about that. In fact, WebPageTest Live is going to be a lot of different things. We're going to do the classics, sort of like auditing that we all love, that you guys all came for. But we're also going to have some really interesting stories. Like we're going to ask developers to join us and just talk about their journeys in performance, what they do, little things like that. But we're also going to do things like, have like-minded content. For example, we're going to start a series soon with the good people at the Web Almanac, and more on that a little later today. But for sure, we are going to essentially sort of, handle all things performance, all things user experience, which is what we know and know very well. That being said, okay, I see the comments coming in. Yes, that was a Sydney reference. Thank you very much. But beyond what you just heard, which is, again, the fact that we are going to, do a lot more content on this channel, we're also going to do things like, work with meetups, work with the community. For example, shout outs to Sergey. I don't know if he's in the chat at all, but if he isn't, someone ping him because he's late. But, we're going to work with the New York meetup, Meet for Speed. We're going to work with the Toronto Performance Meetup. Hello, that's what I do. And, certain events, Perf Now, hopefully happening later on this year. We're going to talk about maybe Perf Matters if that comes around. And obviously, we're going to talk about Lazy Load. That's going to be later on this year, probably, I think, mid to late May. More details about that soon enough. Either way, let's get back to the crux of the matter. And today is WebPageTest Live, and we're going to have a special guest. But first, I want to get to how we sort of came about to today's episode. So yesterday, we had a fantastic blog post. In fact, I'm going to bring that up right now. We had a fantastic blog post covering sort of performance and the planet, essentially talking about performance and emissions. And you could actually, if you've not seen it, you could actually go to this link right here and go check it out. An amazing guest blog post from Farshad. I think I pronounced that correctly. And it just got me thinking, because we had CES a couple of weeks ago, and Sony had announced an EV, an electric vehicle. Sony, ye of AV, who sold TVs, are now doing EVs, which I thought was super interesting. But then I sat back and I was like, man, I'm a big fan of automobiles, and I know Pat Meenan's in the chat somewhere. He's a fan of automobiles too. Fast ones, surprise, surprise. And I thought it might be interesting to maybe profile some of the better known EVs around, So I was like, okay, this would be kind of interesting. And I thought to myself, like, who should I bring along to have this EV profiling conversation? I just kind of poked around and I thought to myself, why not reach out to a good friend of mine? And I'm actually going to bring him on stage right now. Bingo. Hey, and here's our surprise guest today, uh, Mr. Paul Calvano. Do you know that your mic is off?
I know it's off now.
Okay, there we go. I mean, I had to save you there because, I'm the one who had the hot mic for a hot minute, and that was kind of embarrassing. But anyhow, Mr. Paul Calvano, thank you first of all for making some time to join us. And I have to let people know I reached out to Paul because I know we're in 2022, I guess a couple of years ago. I remember you had organized this sort of kind of like a weekly kind of a meetup where you were profiling a lot of sites in and around the COVID situation, and I thought that was super interesting. And I think what that went on for about like 4 or 5 weeks. We did that. Is that correct?
Yeah, it was a lot of fun. I remember one of the weeks we had a large team from the NHS join, and we got to go through a bunch of their websites, and it was a really good time.
Yeah, it was really good. So I just thought it'd be right for you to, or for me to ping you and to see if you're available. And I'm super happy that you were. So we're actually going to sit back and go through some sites with Paul. And, in particular, well, I'll let him name them in a hot minute. But, Paul, an amazing engineer. Him and I think, met a few years ago at a conference. I want to say, was it like,
It was the last Fluent conference, I think.
which one?
I think it was the last Fluent conference.
You are absolutely correct. It was the last Fluid conference. It was my first and last Fluid conference, which was unfortunate, but I used to follow it online. But yeah, Paul's a fantastic engineer. He was also, I don't say was, but he's also part of the guts of the Web Almanac project as well. Now we'll get into that a little later. But yeah, Paul, did you want to add anything that I forgot?
No, I'm really happy to be here, and thanks for having me on.
No, by all means. And by the way, a little shout out. Can we get some clapping emojis? Paul just celebrated 10 years at Akamai. Yay. I mean, that's
Thanks.
big.
Yeah, no, it's a really really awesome place to be, and I'm having a lot of fun there.
Awesome, awesome, awesome. Well, what we'll do is, I believe you should have, I think, sharing privileges at this point,
I do.
and we'll probably just get started.
Cool. Let me go ahead and share my screen. So yeah, when Andre reached out to me last night, one of the things that he wanted to do is take a look at some of the vehicles that were. Can you see you can see WebPageTest on my screen,
Yep.
right? Okay.
Perfect.
He wanted to take a look at some of the electric vehicles that were being announced at CES, and I'm not as much of a car enthusiast as Andre or Pat are, so I know very very little about it. But Andre had given me a couple of websites that we can look at: Tesla's Model 3, BMW's iX, and the Rivian. And
yeah. So let me jump in real quick. And first of all, Paul, I know Patrick is hugely disappointed right now that you're not an automobile fan.
you can kick me off if you want.
I won't, but I'm sure Paul. I mean, Patrick may have some words for you afterwards. But as Paul just mentioned, I was like, what are the big hot topics in EV and the hot companies? And I remember again, CES this year, BMW was buzzing for a hot minute because they had this car that was changing color. It was going from black to white and back again. I thought that was kind of interesting. So I was like, oh, let me look at the BMW offerings for EV. And they have an M series EV, which was kind of surprising. And then, I mentioned Rivian simply because, and I think I'm pronouncing this right, Rivian, simply because that they'd been buzzing and, they're worth $70 billion and they sold 11 cars last year. So I was like, hey, they must be like pretty big. So I threw them into the hat, and I threw in Tesla for obvious reasons. But what I didn't realize is Tesla 3, the Model 3, is one of the best-selling cars on the planet right now, which I had no idea about, and which I think is pretty impressive. So I was like, let's throw Tesla 3, Model 3 into the mix. So that was the reasoning behind those three picks. So that said, Mr. Calvano, I'll let you sort of proceed with your magic.
Sure. So I was actually chatting with a couple of my colleagues about this this morning, and Michael Gooding had mentioned to me, wouldn't it be amazing if these vehicle websites could load in the time that the vehicles can speed up to 0 to 60?
That would be funny.
You know how easy it is to nerd snipe me because you do it quite often. So I wound up, while we were getting ready for this, I wound up writing a query in the HTTP archive to pull out some of the core web vitals and a few other stats from the Chrome user experience report. And so this SQL query just extracts a couple of metrics from this materialized table that Rick Viscomi created. And what you can see here is that the Tesla, the P75 or LCP is faster than going 0 to 60, which is pretty incredible.
I mean, we don't want to give Elon another reason to brag now, because that would be crazy on Twitter,
All of these sites, the P75s are really great. And so forth. It was also interesting to me to see kind of the let me zoom in on this because I'm sure it's hard to see. So what was really interesting to me is seeing the kind of the difference in the percentage of traffic. Like BMW has 52% of their traffic on desktop, whereas Rivian's only 35%, and 42% for Tesla. So there's definitely big differences in terms of the mobile density. Rivian seems to be the one that has more mobile traffic than any of them. But the scores and the performance numbers, definitely look pretty good.
Interesting.
But then since we're here to talk about WebPageTest, what I wanted to do is pull some of those sites and just run a WebPageTest measurement. So I use the default settings in WebPageTest. We'll look at Tesla first. And I didn't do much analysis on this. I just kind of ran the tests. So this is more or less a live audit. So this particular measurement was run with the default settings. So it's a 5 megabit connection. I ran it from Virginia and EC2 on a Chrome desktop browser. You can see the real user data from Crux. By the way, I'm almost embarrassed to say that when I wrote that query, I did not realize that the P75 numbers were actually in this. So like when I came back and I looked at WebPageTest after I wrote the query, I was just like, really? And that's one of the things I love about WebPageTest is that like every once in a while I find a feature that I had no idea existed and it's been there forever. Sometimes I'll ask Tim like, hey, when was this like added? And he'll be like 2 years ago. and it's I just love how it's so on top of things and how much the UI has improved over the years. So let's take a look at the Tesla 3 one. And you can see that, first of all, the waterfall, like the number of resources on this waterfall is really, really small compared to, what you might see on a lot of websites. I mean, there's definitely some heavier resources in terms of, large images and large video files. If we look at the connection view, I often look at the connection view to see like kind of where we're spending most time. And I think that a lot of websites, you'll either find that they're bound either by CPU, like JavaScript, third parties, or they're bound by bandwidth. And it looks like, just looking at the sheer amount of media content on this page, that it's very much, bound by bandwidth. You can also see that in the bandwidth graph here, where we're constantly at the 5 megabit connection that we've defined for this test. So the test is really limited by the bandwidth that we're using to measure it. If I ran this with FiOS, it would probably be a lot faster. But I ran this with a 5 megabit connection, and this is kind of what it looked like.
Very kind of like pedal to the metal the whole time.
Yeah.
Oh man, pardon that pun.
That was good.
I didn't even think of it.
Now, the green vertical bar here shows the largest contentful paint. So on this particular page load, the largest contentful paint happened in around 4.5 seconds. And the largest content play happened before the video is loaded, which is nice. And one of the things I often do when I'm looking at the site is I'll kind of look at like what's happening before the page starts to render and what's happening after the page starts to render, right? Because these are two like really key areas where you can kind of focus on. Like if I can optimize what's happening before the page starts to render, then I might actually be able to influence the entire page load, and then the rest of it all comes down to user experience and so forth. Just kind of looking at some of the things in the waterfall, I can see, so this, the HTML is 374 kilobytes. It's compressed. If I look in the response headers, I can see that it's using gzip compression. Looks like there's some headers here that provide some indication of what's going on at the origin. So it looks like they have some caching at the origin, and they're caching their HTML for 10 seconds as well, which is nice. So they're caching the HTML in the browser, but it's like a very quick revalidation. So if the user is refreshing it, they're most likely going to do a revalidate and not download the full 374 kilobytes.
Which site is this, by the way?
This is Tesla.
This is Tesla. Now, did I just see that Tesla's on Drupal? Am I dreaming?
Well, that's what the headers say.
Amazing. Okay, Tesla. Modern cars.
Yep. Okay. So I can see that there's 3 critical CSS resources, and then it just starts downloading images right away, right? And the first image that gets loaded is this hero image here, so Model 3 Hero A desktop. If we take a look at the response headers for this, I can see that it's a JPEG image. It's 352 kilobytes. If we look at a couple of the other images, I can see for some of the images they're using AVIF as well, which is really nice. You can see that they're using modern image formats. The one thing that I was a little bit concerned about with this particular image, the very first image that was loaded, is that if we look at the actual image, it's not the first image that's on the page. So it looks like we can kind of dig into DevTools to figure out where this image is being loaded. But it looks like they might be preloading the image, or maybe doing a hint to load the image earlier. But the first image that actually loads on that page is this one here.
Yeah.
And the first image that should load is that hero image, in my opinion, and that's actually over here. So it loads
wow,
pretty late.
Absolutely. By the way, for everyone watching, and if you feel like sharing some of these findings on Twitter, let me just give me a quick second here. Let me go back here. Banners. By all means, tag us in a tweet at Real WebPageTest, and use hashtag WPT Live so I could potentially keep track of it afterwards. But there's some very interesting stuff here. So I just love that it's a Drupal site using AVIF. Like, talk about the extremes there. Like not modern and cutting edge at the same time.
Nice.
NASA is also on Drupal. Okay. Well, maybe someone will want to fly with NASA now. Like,
I noticed that Michael Gooding wrote in the chat that too many of these car puns are going to get exhausting.
Michael, whoops, wrong one. Where is he here? Michael, I saw you somewhere. There we go. Yes, that might be the case. So thanks for joining, Michael. Been a minute.
Right.
But again, but getting back to what Paul just mentioned there, like, I talk about the investigative nature of performance profiling, and you start to see these, I don't want to say it's bizarre behavior, but they're loading an image that is not being used as a hero image, and the hero image is way down the chain in terms of loading order. So again, these are the discoveries that you'll make once you start to dig through the in WebPageTest and understand, like, hey, this might need to be bumped a little, a few notches to hopefully improve the the user experience and load times, et cetera, et cetera.
Mm-hmm. So one of the things I want to do is I want to try to figure out where that image is being loaded. So I copied just the URL for that image, just the file name for the image, and I loaded the page in Chrome, and I'm now filtering by DevTools, so I can see the image loading over here. I can see so I can see the all the details on the image, and I can also see the initiator, so I can see exactly where that image was loaded from. I'm going to go ahead and click on the initiator to see where that image is, and so we can maybe get an idea of why that image could have loaded so early. So this image was loaded in a picture element. It just, from the looks of it, it looks like it should have loaded much later than some of the other images, because now if we take a look at the headers, I wonder if it's preloaded. We can also take a look in the chat. I'm sorry, in the we can also take a look to see if there's preloads in the HTML, and there aren't. Let's actually go back to the response headers and see if they have any preloads or prefetches in here, and I don't see one. So it's really interesting that that image just might. And if anybody sees it on the chat and can figure out why that image happens to be loading first when it's so late in the HTML, that would be interesting to me. But yeah, it's I definitely see there being some benefit to lazy loading on this site. It's not doing lazy loading. But if it was, then this image probably wouldn't have been loaded so earlier, and this one may have popped first.
Mm-hmm. And a quick mention, my man, Mr. Herschel, I'm not bad-mouthing Drupal. I'm just having a little bit of fun. But, maybe I'll reach out and we could do some Drupal profiling, so we could talk about that offline.
Mm-hmm.
All right, didn't want to interrupt, but proceed, please.
Looks like Pat wrote in the comments that the separate origin, so it doesn't get prioritized against the images on the main origin. I'm still not sure why that, because both of these images are on that separate origin. They're both on teslacdn.thron.com. So I'm just still not sure why one would be fetched much later.
So Mr. Meenan chimed in. The main hero image is a background image that doesn't get discovered until layout, which is why it loads so late. Preload could help it load sooner.
Cool. Thank you.
Merci, Mr. Meenan, pardon me. Vroom, vroom.
Vroom, vroom. Alrighty. Another thing I noticed here is the fonts that are loading. So the fonts are loaded on a separate domain. So it's cdn-design.tesla.com. Mm-hmm. They're using WAF2, which is good. WAF2 is, I think, if you're probably one of the better font formats to use because it's broadly compressed. And they only have 3 fonts, or actually 4 fonts. Some of these, we can take a look at some of the sizes of these. We got 59 kilobytes and 58 kilobytes, 7 kilobytes, and so forth. I always get a little bit concerned when I see the fonts loading before the page starts to render, because it makes me think that the fonts might be blocking. I think the best way to determine that is to look and see how the font is actually loading. So if we go back into DevTools, I'm gonna just find the fonts and look at the initiator for those, and we'll take a look at the CSS where the font is defined. And sometimes that works. Okay, let's go and search for the font file name. There we go. So it looks like they are using font display swap. So that's good. So it may just be coincidence that the largest contentful paint didn't pop until after these fonts were loaded, because the fonts are not required for rendering the page. Let's see, what else do we have here? We do have a couple of large videos. The videos are loaded later in the page, which is nice. in some sites where I see the video loading a lot earlier, you wind up being in a situation where the video bytes could sometimes compete with the rest of the resources for bandwidth. So it looks like they're doing a good job of not doing that. Still, a lot of these images, I think the images are really what's pushing out the load time here. So lazy loading would probably be a great improvement for them in terms of performance.
Yeah. And, I've always felt like some of these sites were very great examples of sort of, resource management, just because of the nature of their business. Like you have to see how, amazing the interior on the Tesla is,
Right.
X, Y, and Z. So, and, I'm always kind of curious to see how individual companies go about this business of making sure, hopefully, of looking after a good user experience and performance, right?
Yep. Looking at the three JavaScript files I see here, they're loaded early. So line number 11, this script, it was 230 kilobytes compressed. Yeah. And if we take a look at the response headers, we can see how it was compressed. So this was gzip compressed.
Interesting.
One of the things I like to do with especially the largest text resource on a page is try to get an idea of how much Brotli compression would help out. There's a tool that I wrote a while ago that will take a URL and it just runs a curl request with gzip and without, and with Brotli and without, and then it runs Brotli and gzip compression against the uncompressed resource to just see how much smaller it could be. And so what I can see here is that this resource was served with Brotli compression level 9. So they set up the compression level as high as it will go, which is nice. That's why they got from an 800 kilobyte file a 236 kilobyte response payload. They went to Brotli compression level 11 on this. They could actually shave off about 25% more, so that 236 kilobyte resource could go down to 177. So that between that and the lazy loading, I think would probably be some of the biggest bangs for the buck that Tesla could do.
Yes, and it was funny because the few times you did sort of bring up compression, and I hadn't seen anything Brotli related, and I was like, okay, I mean, there's not wrong with gzip, but it is 2022. I thought I'd see, Brotli being mentioned a tad more. Did you? Is it possible that you share that tool URL in the chat?
Sure, let me go do that right now.
That'd be awesome. So we can just kind of flash that out. And for those, I'm sure I'm surrounded, or we are surrounded by some amazing and well-learned performance folks in here, but for those who may watch the video afterwards, you may ask yourself, well, why is it not on 11? Well, there's always a bit of a trade-off, just for those who don't know, you can go with the heavy compression and the music as loud as possible, but at some point you do want some like speed in its processing of the files. So like, yeah, you could have it on 11, but the compression might take a little longer, and these things tend to sort of oh, there we go.
When I created this tool back in 2018, I had done some research using Squash. So Squash has a bunch of compression benchmarks that you can download, and so I just visualized some of the data that they were presenting. And one of the things that you can see here is that with gzip compression, the compression speed goes down with every compression level. The decompression speed remains pretty constant, right? And gzip compression level 6 is pretty much the default on most servers, with the exception of Nginx, that the default is 1.
Wow.
Yeah, so if you use Nginx, check your gzip compression levels, because that you might be doing yourself a disservice if you have the default. But gzip compression level 6 is the default for Apache and a few of the others. I think it's the default for IIS, but I could be wrong. If you look at the compression ratio between gzip level 6 and gzip level 9, there's not a whole lot of reduction. So really using anything between 6 and 9 is probably fine. 6 if you're using dynamic content. 9 if you're using if you're pre-compressing, I think is probably appropriate.
Mm-hmm.
When you look at Brotli, you can see kind of the same distribution amongst compression speeds. And so the Brotli compression level 1 generates a much larger payload than even gzip level 9, but it's a lot faster. And with every compression level, it gets slower and slower and slower. The compression ratio gets higher.
Yeah.
Now, if you look at what you could do with gzip compression level 6 at 3.15, right? You're still your compression ratio is going to be higher at almost any of the Brotli compression ones. This 35 megabit per second compression speed is going to be more comparable to Brotli compression level 5. So if you're serving HTML Brotli compressed, I would do it with Brotli compression level 5. If you're serving pre-compressed static resources like JavaScript and CSS, and it's not going to impact, like the compression time is not going to impact the user, then I would go to Brotli compression level 11, which is 50 times slower than gzip. 40 times slower than gzip, right? So it's considerably slower to pre-compress these, but if it's not impacting the user, then it's just time spent elsewhere.
Insights.
Yeah.
Insights. Amazing. I think I remember this blog post as well, actually, because the minute you brought it back up, I was like, oh, I totally remember this. And that's probably where I remember this sort of, trade-off conversation I just had. So thank you very much for that. Did you want to drop that link to that blog post? Oh, there. Well,
I think that thinking about it now, I think there's actually more recent research in the almanac. So the HTTP Archive Almanac has a compression chapter. So I'll drop that link in there as well, because so this was pretty good deep dive into how sites are compressing text-based resources, and it also goes into some of those recommendations for compressing compression levels that are recommended for dynamic versus static.
Awesome. That's awesome. And we're definitely going to get as I mentioned at the start of the program, I guess we are going to start to have. We're going to further some conversations with the good people at the HTTP Archive Web Almanac. And, I'll get into the details at the end of the show. I keep saying this at the end of the show, at the end of the stream. And, but yeah, I mean, that's awesome documentation right there that I'll make a note of and maybe bring in the author.
Cool. Awesome. One of the things that I was very impressed with here is just the limited number of third parties. Right? So there's 7 third parties here: Google Analytics, DoubleClick. It's really, really impressive that it's just this small of a list.
That is very unusual.
Yeah.
And who was talking about this just recently? I forget who, but they're just talking about third parties, and it's kind of like you just have to manage them. That's pretty much it. Shout outs to Zach Tolman, who sort of used to talk about that back in the day when he had done some talks with Condé Nast, and just saying like, he wasn't going to be able to pull them out. He was just, his conversation was more about managing their effect. So.
Yeah. But yeah, so that's why don't we move on to one of the other sites? So what do we want to do? BMW or Rivian?
Let's go BMW. I was actually very shocked that they have an M series EV. Like, what is going on there?
I don't know what any of that means, but okay.
It's all good.
So in this case, you can see that the real user data from Crux is showing that the P75 for LCP is a bit slower. So it's 4.1.1.4. I think that this view is based on the URL, not based on the overall domain. Someone can correct me if I'm wrong on that. I think Barry wrote a blog post about it, so he probably will correct me if I'm wrong.
I'll wait for Tune the Web to chime in.
Yeah, but, So now with BMW, I can see just a ton of small CSS resources.
Wow.
And so if we take a look at some of these resources, you can see like 0.8 kilobytes, or actually 2 kilobytes, 0.13 kilobytes, like really, really small. So it looks like they're not doing bundling of these
Mhm.
resources. And one of the things that you might say, hey, 0.3 kilobytes is nothing. Why are we even like worrying about this, right? Um, the browser spent 2.2 kilobytes of data to request 0.3 kilobytes of response. So
Amazing.
there's definitely a bit of waste going on here. That
Do the math, folks. Do the math.
Now the other thing is like when you think about the way that compression algorithms work by like building dictionaries and then using those dictionaries to compress resources, and it's probably a very primitive explanation of how a compression algorithm works, but the more bytes you have to compress, the better your compression ratio is going to be.
Mm-hmm.
And and that's why like sometimes you'll see that like HTML compresses better than JavaScript and CSS compresses better than JavaScript, and it's really because of the repetition. When you have a small resource like this, right, this uncompressed size of 0.8 was compressed to 0.3, and so it was maybe a 60% compression ratio, where with like some of the larger files, you might see 80 or 90% reduction in file size. Now, the 0.5 kilobytes means nothing, but if you sum all of this up and compare the amount of bytes received for all of the resources on this, like all of the CSS resources, and compare that to bundling it all together and then compressing it, you might find that there's some byte savings to be made by doing that. And there's definitely probably some byte savings along the wire for the request payloads as well.
Yeah. Because at first I was like, man, why all these little requests? And I realized they're on H2, but as Mr. Meenan would probably remind me, and I'm not sure, but they may not be on a tuned server, and who knows what's taking place thereafter. But
And
wow.
there's often this I almost kind of see it like a tug of war between like people saying compress these resources and I'm sorry, like a bundle of these resources together because you have a smaller payload and less to transfer, and then unbundle this because you're creating such a large payload that it's wasteful.
Mm-hmm.
Right, and so it's kind of hard to get that balance, right? Like
Yeah.
bundling is beneficial, but if you bundle everything and you've got like an e-commerce website that's got all your checkout JavaScript being loaded on your homepage, you're probably doing a disservice to that first view. It might be better later on, but you got to hope they get there.
Yeah.
But so there's definitely a balance. I think that like a lot of times I'll see like this at both extremes, right? You've either got a lot of really, really small resources and no bundling, or you've got a large payload and bundling. But I don't think there's really any great tools out there. It's really just kind of doing the work to figure out the proper bundles and like what's being used. DevTools has like a really great feature that gives you some insight into your code coverage, so you can see
Yep.
like what resources are being used.
Yep.
That could help a developer
Have some insights and know what's
yeah.
quote unquote wasteful,
Yep.
and whatnot, and is being sort of parsed for no reason.
Yeah, and we can actually do that over here. So I'm going to pull up the BMW webpage and just click the record button on this code coverage feature, and we can see what the how much of the bytes are unused on this page. And it seems like it's quite a bit. Like the JavaScript, OWDTM is mostly unused, but then bytecode is mostly unused, probably because I didn't scroll that into view.
Mm-hmm.
And then a lot of these CSS files that are pretty small. It's how much of them are unused. I think a lot of the CSS is not being utilized. So bundling it would probably make that even more evident in a tool like this, because you might see that. But I think that there's some cleanup work that could probably be done.
Yep. And again, some testing essentially, to see what comes of it, and what doesn't.
Yep.
It's quite the waterfall.
It is quite the waterfall. One of the things one of the features I really like about WebPageTest is the ability to customize the waterfall. Mm-hmm. Because I mentioned that one of the first things I always do is try to figure out what's going on during that critical rendering path, and like what's happening before the page starts to render. Mm-hmm. And in this case, that's like 10% of this waterfall. So it's really, really hard to kind of make sense of like what's slowing things down here, other than things we've already mentioned. And there may not be anything other than that we see here, but I love this little feature. That this is probably one of those things that you can use WebPageTest every day and not know it's there. Mm-hmm. So definitely take note of this. But you can set a maximum time. So I'm going to set a maximum time for 1 second, and now I can see the waterfall graph updated, and I can see actually what's going on here. And what's interesting here is that you see a bunch of these resources loading before the first byte of HTML. And I believe this is either preload or server push. We can go and take a look in the waterfall to see what's going on here. But they're definitely loading some of the critical CSS and JavaScript early. So let's actually go up here and take a look at the response header for the base HTML. And so what I can see here is this. They've got preloading for fonts. So they're preloading their fonts, and then they've got pre-connect headers for this. Doesn't look like they're preloading, at least in the response header, some of those CSS files. But maybe you might see that elsewhere. It's interesting that these are. It does say that this JavaScript is server push, though. Oh, there we go. So that would explain it. So H2 server push is pushing these resources early, and then they're also using preload to preload the fonts, which is why these resources are the first ones that get loaded on the page. And you can see that most of it
just mentioned something here. If you go to the LCP view, it will trim the waterfall to the LCP.
Sorry, say that again?
Pardon me?
Can you say that again?
He had just mentioned, I don't know if you can see it on your screen at all, but if you go to the LCP view, it will trim the waterfall to the LCP.
How do you do that?
And hold on. Oh, here I'm thinking I'm controlling the screen. LCP view. I don't see it right away.
If you go to the LCP, sorry, are you saying going to the to the Web Vitals dashboard?
Main results page. Click LCP.
Yes. There we go. Well, actually, which one was it? Click LCP.
There it is.
Yeah. The LCP was still at about 8 seconds here.
Wow, this waterfall is amazing.
There's definitely a lot going on here. Now you can see the pre-connect in action over here. So it looks like SpeedCurve and Adobe DTM pre-connect was setting up that connection early, so that when the browser needed to make those requests, it just fires off the HTTP request.
Yeah, it just sits. Yeah, it just sat there on its own. You're like, hey, what's going on here?
Yeah.
Any more sort of unusual, interesting? I shouldn't say unusual, but interesting findings from the great German company.
I don't know. I'm looking. Let me go back to.
Wow! Look at that LCP image. Amazing.
So they definitely, if we look at the connection view, you can see. Well, first of all, there's a lot more third parties here. We can also see, there's definitely lots of images, but also, some of these third parties are loading before that onload event fires. The LCP event happens over here. Now that LCP image was loaded before was loaded before it became visible on the page. So that may be something for them to investigate as well as potentially what JavaScript or third-party resources could be blocking that the rendering of that resource. Maybe they're fetching a resource with JavaScript, or maybe they've fetched the resource and they're holding it back until some of the other JS modes or executes. Hard to say for sure, but yeah, there's definitely some work to do here.
Nice, nice. Again, the investigative nature of the work, and you start to find little unusual bits of behavior from your resources.
Yep.
Cool. So that's BMW. We looked at Tesla. Who was last? I think. Oh,
Rivian was
Rivian.
last, and they also had the CES webpage. Let's take a look at Rivian. Now you'll notice that on all of these websites, there's large videos,
Mm-hmm.
um, and the load times are very heavily impacted by these videos as well. So um, the metric that you're using to measure becomes very important here, because if you're looking at largest contentful paints, like
Mm-hmm.
I've got a 1 second page load time, right? But if I'm looking at the total the on load time, it's around 25 seconds. So this is a huge discrepancy here. What's actually meaningful here um, is the largest contentful paint really indicative of what that user experienced?
Mm-hmm.
To do that, I would typically go and look in the film strip and try to get an idea of what's actually going on during each of these milestones. So
Mm-hmm.
in this case, like once we hit that 1.5 seconds, so this was the largest contentful paint, and it looks like the largest contentful paint wasn't even the. Let me actually change this to 0.1 second just so that we can see. But the largest contentful paint was actually this background.
Wild.
And
The
not the
actual,
background.
not the actual image.
And then yeah, that's really interesting. That I mean it was a second later that the actual largest contentful paint was displayed.
Mm-hmm.
But yeah, no, that's interesting. I don't know what might have caused that to pop earlier.
And that actually might even be a carousel. I remember poking around yesterday and I was like, man, I think this is a carousel. But either way,
I hope this isn't the first image in the carousel.
I'm like in my head, I'm just kind of like thinking, because I remember I was like really poking around the page yesterday. I was like,
Yeah.
what is going on here now? But interesting finding again, numbers don't lie.
Yeah. And you can see that so they've got some really large JavaScript over here.
Mm-hmm.
And it looks like with the H2 prioritization, it's the images are still kind of getting priority over the JavaScript, which is really interesting. And I think that maybe because it's on separate domains, as Pat mentioned before, we've got media.rivian.net and rivian.com, so two separate domain names that have their own priorities. So because of that, you wind up having the images and the JavaScript competing. It might make sense to collapse these into a single domain name, or at least coalesce them onto a single connection.
Hmm. Wow. Okay. Rivian. I mean, if they spend as much time on the website as they did building, go ahead.
2.3 kilobytes, 2.3 megabytes of uncompressed JavaScript is massive.
Don't get Alex Russell in here. This whole stream will explode. Shout outs, Mr. Russell, Microsoft's finest.
Alrighty. Curious to see how much. What Broadly level they're using, or what gzip level they're using, as well. So this is gzip compressed. Let's actually run that through the tool as well and see what happens.
2 megs of JavaScript. That's stunning.
Yeah.
Again, I just thought it'd be an interesting look because they're getting so much buzz and attention.
So this one's interesting. They are broadly compressing the resource to broadly level 5.
Mm-hmm.
So they've gzip compressed it to gzip level 7.
Mm-hmm.
Probably it's either gzip 6 or 7. It's really close.
Mm-hmm.
But broadly compression level looks like it's around 5. Mm-hmm. Now, if they went to broadly compression level 11, it could shave off like another 70 kilobytes.
Uh-huh.
But what was interesting to me is that when we loaded this image in WebPageTest, it didn't actually return the broadly compressed resource. So I don't know what. Maybe it just wasn't compressed in time, or maybe it was Was it a cache hit? Yeah, it looks like it was a cache hit. So yeah, it's interesting. I'm not sure why that wasn't sort of broadly compressed, but it looks like the server at least is capable of sending it broadly compressed.
Mm-hmm.
And it's broadly compressing it to broadly level 5. I'm guessing it's doing the real-time compression as a result of that to try to, and it's probably using broadly level 5 in order to avoid impacting the user with the higher level.
Yeah, and slower times. Well, okay.
Cool. I know we're almost at time. Did you have any direction you wanted me to focus on, or did you
Oh
want to?
no, I mean, like I said, I think this was mostly sort of like an exercise and sort of like poking around, see what is actually in there that we can sort of pick up, investigate, and see what looks potentially unusual. Um, but yeah, I mean that was like there were some for sure interesting findings here without a doubt. I mean, I think you'd mentioned there was something else that you may have wanted to take a quick gander at, or was I sort of dreaming?
No, I don't think there was.
Okay,
Yeah.
yeah, awesome. Well, I mean, this is again, I get back to comments I've made on Twitter before, and I've said it live tonight or today, pardon me, a couple of times. Is that the what we love in this space is that we can actually look at requests individually and see exactly what's going on, and what resources are coming in early, coming in too late, aren't compressed properly, potentially little mistakes that are made along the way that are pushed up right to production, and these aren't big deals, but we're just here to sort of like find out, and that's really it, and that's what we do at WebPageTest. Let's go. But that being said, Mr. Calvano, first of all, thank you very much for your time. I do realize that this was a bit of a last second request for you to come in and fill in some shoes. But I mean, I'm one who's always appreciated your acumen in this space. So I do want to thank you for coming in and filling in that spot. Now, for everyone out there, if you're not following Paul, I think you absolutely should be. You're not living right. So his his Twitter handles there, Paul at Paul Calvano. He has amazing content on his blog. He's also written some fantastic pieces over at the HP Archive, at the in the discussion page, which actually brings me back to the point I want to make. Now, I spoke about working with the good people at HA. Shout outs, Rick. And where is he here? I know he's around here somewhere. Shout out to Barry, who's somewhere in the chat. But we're going to be doing a series of having a series of conversations with them as well, talking about the Web Almanac, some of the data that we pulled out today in the conversation around compression. And subsequently throughout the next 2 or 3 months, we're going to have like these sort of AMAs with some of their contributors. Speaking of AMA, I also wanted to mention that we are going to have, believe it or not, a WebPageTest AMA with members of the WebPageTest team. And that's going to be taking place sometime early February. So look out for that. We're going to be announcing it through our Twitter handle, Twitter page at Real Web Page Test. I'll be mentioning it as well at my Twitter handle, which is Henri Helvetica. And that's going to be a super event because we're going to be able to talk about, everything Web Page Test. You'll be able to meet some of the members of the team, and we'll sort of like fill you in on some of our plans as well. What else did I want to talk about? First of all, our next live is going to be January 14th, 27th. So make sure to come back for that. Maybe some more surprises. Speaking of surprises, if you ever want to be on, let us know. Ping us on Twitter. Ping me on Twitter. We're definitely going to have more guests, talk about more things. Mr. Herschel, maybe we'll talk Drupal, how to make performant Drupal. And we'll also talk about your 49-inch, ultra wide monitor. I mean, I want to make sure that you're still good with that. Oh, shout out to my man, Jason in the building. Let's go, Netlify. And what else did I want to talk about? Oh, please give us a follow at Real Web Page Test. We're going to be your best Twitter neighbor, rest assured. But if you're into the performance space, we are going to have a lot of content for you in the months coming. And I think that's all I want to talk about. Yeah, I think that's it. So once again, everyone, thank you very much for joining us today. That was a lot of fun. I hope you caught most of it, if not all. Beyond that, we're actually going to get the recording edited, and we'll get it back up, hopefully maybe next week. And you'll be able to sort of go back and parse some of this information that Paul Calvano was so nice to bless us with. And with that, I think there's like another 40 seconds. You know, Paul, did you have anything to share?
Nope.
Oh, come on, man. You know, ye of Akamai, let's go. You must have some gems. You must have some gems to share.
In 40 seconds, right? No pressure. Well, thank you so much for having me on. This was a lot of fun.
Oh, thank you very much. And last thing I am going to mention, if you have never used WebPageTest in your life, you know, there's no better time than the present. Let me go back and get into my banners because this is amazing right here. Bingo. Go check it out. Get yourself an account. We'll be talking about some of these details as well at the WebPageTest AMA. It's going to be a lot of fun. And yeah, just give us a follow. And that being said, merci beaucoup. Thank you very much for joining us. And we'll catch you in a few weeks. Cheers.